Welcome to Learning Beyond again. We have already started the analysis concepts on two-way slabs. This is our today's second session on two-way slab. So we will continue today to understand the boundary conditions of two-way slab as per IS code. So before that, let's try to understand some concepts regarding that boundary conditions. So let me take one example of let's say this is a slab. I'm taking analytical example. So let's say the slab is, there are three slabs. Let's say this is slab S1, S2, S3. Okay. And there is a load on that. And all of you know that slab rests on the beams. So these arrows are nothing but, let's say, beams. So beams or supports, we can say, beam supports. Now you can see that there is no slab in this left side. And for S3 also to the right, there is no slab. If you consider S2, then you can see to the left side, there is a S1 slab of this S2. And to the right side of the S2, there is a S3. That means there is a continuity over here for S2 and also here. So if I draw the bending moment diagram, as there is no slab to the left of S1, I will consider this as a simply supported, or this edge we generally call it as a discontinuous edge. Discontinuous, because there is no slab continuous here. Discontinuous at this point. Here you can say for S2 there is a continuity to the left. So this I can consider as a continuous edge. Okay. Continuous edge. Then this is also continuous for S2. Even S3 also, because to the left there is a S2. And this end is discontinuous. So these words are important. As it is a discontinuous, there will be zero bending moment. So if I draw the bending moment diagram, then it should look like this. There is a positive or sagging moment here. Then as there is a continuity, we will have a negative moment or support moment like this, similar to fixed condition we can see. And here also, again, there is a continuity, so there will be negative moment here. And again here and at the discontinuous, there is a zero moment. So these are zero moment or simply supports or discontinuous edges. So you can see for S2, if you look at the bending moment diagram, it is similar to fixed condition. So last time we have seen that case. So we have assumed the slab as a fixed, and then there is a bending moment like this. So if it is a two-way slab, then there will be two moments. One is in this direction. Let's say this red moments are My moment, for example. So My positive, My negative, say for example. Then there will be other direction moments which are Mx short span. Let's say this is a long span of the S2, Ly, for example. On the other direction also there will be Lx span. So you cannot see in this picture. Now this is your boundary conditions, discontinuous edge and continuous edge. And in IS code, in this table, they have given table 26. There are different conditions given. Interior panels, one short edge continuous, one long edge discontinuous. So what is meant by that? Actually, instead of this, we will see in the picture format. Okay. So if you see this picture, it will be easy to understand. Now this dark line, thick bold line is a continuous edge, and this thin line is a discontinuous edge. Now you can look at this picture. If you see number 3 is the case here. There are cases 1, 2, 3, 4, 5. So let's say this is the third case, for example. So in this case, you can understand that this is a short edge. You can see short span, and this is a long span. Short edge is continuous, because how it is continuous? Because to the right there is a slab. Then this short edge is also continuous because to the left there is a slab. Then this is also continuous because in this side there is a slab. Now in this side there is no slab, therefore it is a discontinuous edge. So if you look at this third case, one long edge discontinuous. See, this is one long edge discontinuous. That means other are continuous by default. Let's see the first case. First case is the interior panels. Interior panels means all edges are continuous. So you can see here. case number 1. So this is also continuous because there is a slab here. This is also continuous because there is a slab here. For case number 1, for this slab I am considering. Then there is a slab here to this left side, therefore this is continuous. Again, this is continuous because there is slab on the right side. When I consider this case or this slab, okay, so this is the meaning of this continuous, discontinuous. Here also, let's say 7 cases there. 7 case, what is this? You can see this long edge is continuous and all other discontinuous. So let's say what wording is used in the code. 3 edges discontinuous, okay, or 1 long edge continuous, anything. Either 3 edges and are discontinuous and 1 long edge is continuous. So 1 long edge is continuous. Similarly, for other cases, you can see here, you will say that these 2 long edges are discontinuous and 2 short edges are continuous for 6. So this way you can interpret the meaning of this. Now, depending on this continuous and discontinuous, there will be the moment values given. Okay. So let's say, let's take example of 1 number first. So as all edges are fixed or continuous edges, there will be moment at the supports. For example, I will draw the bending moment diagram on this here itself. Now we are interested in case this case number 1 or slab number 1, let's say, for example. So definitely, as it is a two-way slab, there will be moment along long span and there is a moment along short span. Okay. So long span moment I will draw in red color. So here you can say as there is a continuity, there will be negative moment here. And again, sagging moments, positive moment, again, negative moment. Why it is negative? Because there is a slab here. Now in the shorter direction also, there will be negative moment. And again, this and this. We have seen that in our last video. So this is nothing but all edges are fixed or all edges are continuous edges. Now here also in this 3 case, now you can see this is a discontinuous end. That means there will be 0 moment at the support. But here negative moment is there already. So it will be like this, 0. Again, this is a 3 case. So it will be negative moment here at the support for 3, slab 3 also. But here it will be 0 because it is a discontinuous edge. Similarly here, if you see, the moment will be like this, 0 here, 0 here. Let's say these are the lines, reference lines. So here it will be negative, no negative actually, 0 here at the end and only mid span moment. This is a long span moment. And again, there will be here. Now here you can see there is a continuous edge, so there will be negative moment here. Okay. So the negative moment is here. For understanding, let me draw in blue color. Okay, let me overwrite. So here 0, then negative, and then again this one. So blue is short span moment, let's see. Again, long span here as the for 2 number case, there is a 0 here because discontinuous end. So it will be like this. So at continuous end, there is a moment again here. So these are the bending moment diagrams for different cases. If you consider this, then long span moments. So there is 0 here, then negative moment due to continuity. Then again here continuity. Again, this is a continuity and again continuous. Okay. For 8 number, short span will be simply supported case only. Like this. 0, discontinuous ends, 0. Again here it will be discontinuous, so it will be 0 at the ends. So this is the interpretation. Now 9 is the simply supported on all directions. That means discontinuous at 4 edges. So it will be only simply supported case. In the last video we have seen that the simply supported slab case. Okay, and then this is the. So this is the interpretation of all the cases. Now you can understand thick is the continuous edge. Then you can refer the table, and then you can look the coefficient alpha x, alpha y. Alpha x is for short, and there is a short span also positive and negative. For example, here, let me take case number, say 1, as we have taken. So this blue color, so there will be alpha x negative. Okay, here, this one. Then this will be alpha x positive. This one, say sagging moment. Again, alpha x negative. Then for longer span moment, this will be alpha y negative, and this will be alpha y positive. Okay. So this is the interpretation. It is applicable for all. Here also you can see this will be red color, longer span, alpha y positive. And blue color, this will be alpha x positive. And as there is a negative moment here, alpha x negative. Please see the directions, shorter span. This is along the shorter span, therefore it is alpha x negative. So this is the interpretation of the two-way slab coefficients as given in the code. So in table 26, and all other things are that alpha x depends on the Ly by ILX ratio. So depending on your slabs, you can take that alpha x and alpha y values for analysis. So in practice, how we interpret this boundary condition, we will see in the next session by taking some practical examples, so that which case is applicable for that particular problem. So this is something theoretical part, we can say, to understand the technical aspects. Now in practical aspects, how to understand which is the interior panel, or what is this discontinuous panel, or short edge continuous panel, like that. So we will see in the next session. So thank you all for watching the video.